So tonight we're going to talk about performance testing Java applications. So I'm going to ask the most obvious question. Is anybody in here not a Java developer? Okay. So you, sir, with the mask on, what do you build on, just out of curiosity?
Node and TypeScript.
Node and TypeScript, okay. Anybody else? Build on anything like .NET, Python, any of those other things? So for you and a couple of other folks who are here, even if you're not building Java applications, I think you'll get quite a bit out of this session because there is quite a bit of fundamental stuff that I think most people who are doing performance testing miss. So I'm going to spend a lot of time actually talking about that, and then we'll do a demo towards the end, and we'll get into some specific details about Java applications and performance testing them and things like that. But this is not an extremely technical session on Java performance testing or just performance testing in general, because you don't actually have to be super technical. Now, how many people in this room have set JVM flags to try to fix a performance problem before? Okay, so for all those people who have your hands up, you're doing it wrong. Well, we'll see why in a few minutes, okay? So that should typically be the last resort when trying to fix performance testing. Okay. So, hello, my name is Pratik Patel. I'm a Java champion. I help with the Atlanta Java user group here, and I lead the developer relations team at AJUG Systems. Now, how many people have heard of AJUG? Show of hands real quick. Okay, wow, that's less than 30%. All right, so what AJUG does is we compete with a company you may have heard of called Oracle that builds a JDK. And so we have two primary builds that we put out. We have a completely free open JDK build called AJUG Zulu. Anyone can use it. We have literally millions and millions of shops that use that instead of using OpenJDK or Temurin or Adopt JDK or whatever. And then we also have a high-performance JDK called Platform Prime, which is meant for all sorts of things like big data, Spring Boot apps, running Apache Kafka, Apache Cassandra, all those different types of things. And we like to say that AJUG is the best JVM in the galaxy. And I'm not going to talk too much about this, but if you're interested in this, let me know. And I can dive into why that is a bit later. But just very quickly, you get a minimum of a 20% performance gains out of the box just by switching out the JDK. And it is fully TCK compliant. So that means that you don't have to change anything. You literally just switch out the JDK, no code changes. You get better throughput and more stability. All right, so that's enough of the AJUG advertisement. So why listen to this session? Why specifically listen to me? So I currently work at AJUG Systems, and we make a super fast JVM like I was just saying, right? AJUG Platform Prime, and we're major contributors to lots of different things in the Java universe. But previously, when I was working at a big telco that's in Midtown here in Atlanta, you may have, I think they recently changed the logo on the building in Midtown, but I led the Java performance team there for 4 years. So I know a little bit about this stuff, right? And I do not pretend to know everything about it. So yes, there's your little grain of salting, because performance testing, the way that I like to describe it is it's less engineering and it's more art form. Okay, and you'll see that as we go through this and understand why that is. Okay, so let's get on with the show here. And speaking of shows, does anybody know what show this is? Okay, all right, it's Silicon Valley. I had to stop watching this because at the time I was at a startup, and every week's episode was too close to what my startup life was actually like. I'm not joking. It's not a joke. So, but I stated before that performance testing, whether you're doing it on Java or Python or Node or whatever, is a bit of an art form. And so you do need to be organized and prescriptive about, hold on, pull this thing down. Organized and prescriptive about how you approach it, but it's not something where you say, okay, these are the exact steps I'm going to follow to find a performance problem and fix it, or hey, we're rolling out a new feature, how do we make sure it's still, our entire system still performant, et cetera, et cetera. Okay. So, oh, and by the way, if you have any questions through this, please ask when you have the question. Otherwise, we'll only be here for 20 minutes. I'll have to spend the rest of the time telling jokes, which won't be fun, okay? But I have a question for you first. What's the best way to fix Java performance issues? Anyone want to take a guess? Yes, please.
In my experience, use something like
visual VM.
Okay.
Either do profiling or sampling.
Okay, that's actually a really good answer. We're going to actually use visual VM in this. Okay. Yes.
Isn't there a JVM that's like 20% better strategy?
Yes, there is a JVM where you can just drop in and it'll fix all your performance problems. So yeah, you were paying attention. So nice. I'll give you $100 later. Okay, next. Restart the VM. This is actually a really good one. And that is actually not a completely bad answer, because what happens when you restart the VM, you get rid of all the heap, and all of a sudden you have like all this memory that you can start building again and restart it a day or two or an hour later, however. Anyways, go ahead.
Double check your database queries. A lot of times it's not in Java.
That is also a really good answer, right? So sometimes it's not actually Java. It could be your database queries are running too long, which lock up threads in the VM, et cetera, et cetera. Okay, that's actually a really good answer. Yes, Glenn.
They also verify the hardware or the virtual machine that you're running on. Make sure you've got the right sized one. If you are still running on metal, make sure you understand the performance that that can give you so that you have a baseline.
Okay, so Glenn's answer was check the hardware or the virtual machine you're running on, check that there's enough capacity, et cetera, et cetera. That is also a very good answer. Okay, anybody else? Yes, over here. Yes, that's also a good answer. But that's how you scale it. That's how you add more capacity. But not necessarily, well, actually, yeah, you could fix a performance problem by just throwing more hardware at it. And we'll actually talk about that. Okay, anybody else? Yes, in the back. Oh, what about using GRAW VM? Since this is being recorded, we'll talk about that afterwards, okay? We'll talk about it later, okay. Anybody else? These are all great answers, by the way. So you all are doing great so far. Okay, no more? All right. So, and you know this was going to be a trick question. So the answer is it depends, right? So all these answers are actually correct. And in fact, we're going to hit almost everything that people said so far as we go through this, right? So the real answer actually is much more complicated than the solutions that you said. Actually, in my opinion, the best way to fix JVM issues is to actually find them, right? That's, in my opinion, that's the hardest thing. Actually, fixing the problem is far easier than figuring out what the actual problem is by an order of magnitude, okay? So you're like, okay, so then how do I find the issue in a running system? Or say that I'm deploying some new code, a new feature or something, and you want to make sure that whatever changes that you've made, right, whether you're fixing a bug or adding a feature, that your system continues to be performant. How do you figure out that that is still the case, right? So this is much more difficult than it seems on the surface. So what I'm going to do first is I'm going to quickly step through the 9 basic steps that I use to do successful performance testing. And then we'll dive into each one of them in some level of detail, right? I could probably talk for like 3 or 6 hours on each, well, not each one of these, but on all these together. But we don't want to be here until midnight. So I'll get to the parts which I think are more interesting and a little bit more difficult to really understand and get your head around as a performance engineer. All right, so here's the steps. Step 1, set up your performance test. Step 2, run the perf test, ... profit, right? Of course, this is a joke, but the part that we're going to talk about mostly is the dots there, right? The session is mostly about that step. How do you go from being able to run the perf test to understanding what's going on and how do you fix it? Right, so let's start with the first 3 basic steps. Define your goals, think about your environment, and think about your app. So, and I think the first one is actually the most important out of these 3 steps. We're going to dive into some detail on this, okay? 3 steps during testing. So you've defined your goals, you've thought about your environment. Like Glenn said, have we thought about like the operating system that it's running on? Are we giving it enough memory, et cetera, et cetera? Do we have any enough virtual CPU cores assigned? What is our app doing? Right, we'll get into all those things in a few minutes. Right, and then operating system settings. During testing, we also have to use some tools. Someone mentioned Visual VM. We'll look at that actually in a demo in a few minutes. And then, of course, collecting performance data. And once you've done that, we have to analyze the perf results. From that, hopefully, we're able to extrapolate some bottlenecks based on what you've seen live in Visual VM, or you've taken a profile dump, or a heap dump, or a thread dump, or you're using one of the other tools that I'm going to show you that give you additional data, okay? And then, of course, you try a fix and only do one fix at a time, even though we're engineers. We're like, oh, let's just try 8 of these at the time. No, we typically like to just do one fix and then test it, see if that makes a difference before we try something else if that doesn't work or we need additional improvements. All right, so first step, define your goals. And we're going to spend a little bit of time on this, and this is probably the part where most people generally tend to get bored, but this is super important, right? Defining your goals. So if you don't have any goals in mind, aside from, hey, let's just fix the problem, right? Yeah, maybe you have something on production which is blowing up, and you know, I think someone made a joke over there, restart your server, and you're like restarting your servers every night. And unfortunately, that's not really that much of a joke, because when I was a performance engineer at a large telco based here in Midtown, one of the things that we used to do every night, take a guess, we would restart our entire cluster of 150 JVMs running and do a rolling reboot of them. It was the most asinine thing ever, but that's what we had to do just to keep the system stable enough for us to figure out what was wrong. And that was over the stretch of 6 months. Okay? So anyways, performance testing goals are a must, right? A goal can be as simple as make sure the system doesn't blow up, right? Until we reboot it every 3 months when we do a update or whatever, right? Everyone is probably doing CI in here by now, right? Continuous integration and continuous delivery. Okay, I see some heads nodding, but that's okay. It's hard to do for Java apps especially if you're using a legacy or working on a legacy app. Okay. But these are the 4 different things I like to think of. What is the SLA that we have with our business or a customer or whatever? So what kind of stability do we need out of that system? Is it okay to reboot everything once a week or once a month, or does it have to be running all the time? All right, we'll talk about auto-scaling and other things like that later, but that's a little bit kind of outside the periphery of what we're trying to get to. All right, but the other 2 things that I like to think about is there's a trade-off between throughput and latency. Okay, so when you think about, I need to have, for example, 100,000 messages run through our Kafka cluster every minute, right? That is a specific goal that you're setting. But another goal that you may have with that same Kafka cluster is, well, every message needs to be delivered in under 10 milliseconds. But throughput and latency are opposite kinds of metrics, right? You can ramp up the throughput, but what happens to your latency if you push it too hard? Your latency goes up, right? Yes?
So what performance are you testing? Are you testing for speed, or are you testing for ability to handle volume?
Right, that's what these 2 things are. Throughput is volume, speed is latency, right? So that's what I mean, is that they're kind of opposite. So if you ramp up, if you say, okay, I'm okay with more latency, then you can push more messages or whatever, more requests through your system. But if your latency needs to be low, like 50 or 10 milliseconds, then your throughput might suffer. Not necessarily, but it might. Okay, but we'll talk about that a little bit more, so you get an idea of what I mean by that. Right? So let me throw some jargon at you. This is what performance engineers use to think about and quantify the problem so that they can put real goals into mind, right? Latency is pretty easy. You could say, okay, every request needs to be serviced within 50 milliseconds. But is that a realistic goal, though? It actually is not. We'll see what that means in just a second. Let me explain what percentiles mean. So when we're doing performance engineering, we think in terms of P99s or P95s or whatever. We will see what that means in just a second. But P99 specifically means that we're trying to operate all requests under a 99th percentile. So let's look at what that means, right? So when we say P99, that means 99% of the requests should be faster than the given latency. Okay? If we want to flip that around, the other way that we think about this is only 1% of the requests are expected to be slower than whatever our goal is. Okay? Now, let's look at this. I'm going to look at this in a couple of different ways so that you understand what I'm trying to get at here. All right, so when we think of P99 latency, and I just made these numbers up to make the math easy and for you all to follow along a bit easier, okay? So if we look at this, you can see I have latency on the left here. 1, 2, 3, 4, 5, 6, 7, 8 seconds of latency. And these are the number of seconds, number of requests that finished under that amount of latency, okay? So you can see that if we say that, on this chart, 5 requests finished under 1 second, and 5 requests also finished under 2 seconds, etc. So if we add those up, that means 10 requests finished under 2 seconds total, Okay? So of course, if we go to 3 seconds, that means 20 requests finished under 10 seconds. Right, so how do we calculate a P99 latency out of this, and P95? So if we add these numbers up, right, you can do the math in your head pretty easily here. We could say that the P95 for this, whether it's a performance test run or production data, we could say the P95 is 6 seconds, or that 5% requests take longer than 6 seconds to complete. And our P99 in this case is that P99 is 7 seconds, or 1% requests take longer than 7 seconds to complete. Okay? So let's look at this visually in a slightly different way here. Right? And this adds a few more bits of data or different ways of looking at it. So if we're running a performance test or we're looking at production, we might say, you know what, our minimum latency seems to be about 0.1 seconds or 100 milliseconds. Our median latency tends to be 0.2 seconds. But our maximum latency seems to be around 7.2 seconds. And if we had the full data set for this, what we could see in terms of how our stuff is actually running is that our P95 is 0.5 seconds and our P99 is 1.3 seconds. Okay, so that means, again, we need to be able to phrase this in ways that our business analyst or our customers or our manager or other team members, for that matter, understand. So what we would say in this case is that for 95% of users, the latency was below 0.5 seconds so that they understand what we're trying to say. Right? Being able to quantify this and explain to people what that actually means is super, super important because, right, the other folks on your team may understand, but the business analyst, your customers, whatever, may not understand what that specifically means. Okay. Now, if we think about this specific scenario, you may say, okay, you look at this and say, okay, you know what? It looks like most of our users get a response within half a second. And 99% of our users get a response in under 1.3 seconds. Right? And this specific section is about defining your goals. So you might look at this and say, this is actually good enough. 95% of our users get a response within a half a second, which is pretty good, right? Depending on what you're doing, of course. But 1% see latency greater than 1.3 all the way up to 7.2 seconds. Is this acceptable for our users? If it is, guess what? You're done. You go home. Okay, but if it's not, obviously, then we need to figure out how to improve the performance of this system. So this is the trap that we fall into as software engineers, is we always strive for perfection or try to make the system better. And what happens when you start doing that? So instead of hanging out with your friends on Saturday night, you're in front of your computer trying to bring this P99 further and further down when you don't really need to. So this is what I mean by setting goals. You have to set a goal and say, okay, we want at least our P99 or 99% of our users to be able to get a response in under 2 seconds or 3 seconds or whatever it may be, and that's good enough for us, and that's the target that we're going to try to hit. Okay? And there are other obvious things that we need to factor in there. When are we taking these measurements, or what scenario are we taking these measurements in? If we're saying that our P99 will be under 2 seconds at peak load, and that's good enough for us, well, that's basically your goal then. Okay? All right, yes?
So when you're doing this analysis, are you using the same request over and over again, or a similar request over and over again? Because we know in the real world, some of them vary dramatically.
Yeah. Okay, so the question is, when we're running these tests or when we're looking at perf data that gives us this information, what kind of requests are we sending in? Are they the same or different requests? Right? Do we use like a standard set to send that data in? And the short answer, unfortunately, in this case is it depends, right? But what I've done in the past and what I've done with customers at Azul is that we try to simulate production requests and load. But I'm going to talk about that in maybe what you may describe as excruciating detail in a few minutes. Okay, so basically scenarios for live versus stage performance testing. Okay, so we'll get to that in a bit. All right, so again, all these numbers look great, they work for us, but how do we take this and make it into something that other people will understand that are not necessarily technologists? Right, go ahead, yeah.
Why only 99 and 95? Why don't we?
Oh, you can go to P9, you can go to like, P99.9 or whatever. You've heard 2 nines and 3 nines and et cetera. So yes, you can go to that, right? It's
There's no specific reasoning to go for just P99.
yes. So the question is there any specific reasoning to go for P95 or P99? The short answer is no. That depends on you and your application and what your business analysts want. So the obvious example here is that if you work for a fintech company or an investment bank, their P9, they won't be happy with the P99. They want a P99.99999 or typically 5 nines, right? I used to work in investment banking tech, so I know that 5 nines was usually the minimum for outliers in terms of performance. So you're absolutely right. Okay, it's a good question. All right, so how do we phrase that? We want 99% of users to have less than 2 seconds latency, right? So these are words that people can understand. We need to push 100,000 messages through 100,000 messages a second through Kafka. Again, there's terminology that people can understand and other folks on your team can understand, so you can also understand how you scale in the cloud or on-prem or wherever you're running stuff. And we'll talk a little about cloud and on-prem in a few minutes. Okay? So another ways we think about this is our P95 needs to be less than 500 milliseconds, or our P99 needs to be less than 5 seconds. So I generally tend to use both the P95 and the P99 to explain to folks exactly what our targets should be. Or, once we talk to business analysts or whatever, we explain to them, like, this is what we're trying to do, right? So we will have outliers, because there's always outliers in any system, but how much do we want to reduce those outliers, and what do we want the average latency to be? Okay? All right, so if we look at this visually, which we're going to do when we run a demo, and hopefully it works properly, this is how we graph it. So we can see that on the left axis here, we have latency in milliseconds, and this is the percentile, and there's actually a tool that will help us produce this graph so we can see what our curve looks like, and then we pinpoint where our P99 is and where our P95 is, and it's always nice to show these graphs to folks, right? So they can visualize exactly what we're up against. Right? So you can see here, you were mentioning before, here's our P99 and here's our P99.9 over here on the right side. Okay? So you can see that it flattens out. In this case, it flattens out, but it doesn't always necessarily flatten out like this. All right, so let's move on to the second step. So we've done kind of the longest one here so far, and thinking about defining your goals and all those things, but now we need to think about our environment, right? So what does this include? And I don't have a lot of answers for this, unfortunately, because your environment is your environment, right? It's not my environment or whatever, this person's environment. So some things that I'd like to think about when I'm talking to potential customers and we're doing performance testing. Are you running on cloud? Is it on-prem? Is it a single server? Is it distributed? How is it distributed? And then someone was asking about environments and how we run tests, right? So what I have here, the second bullet is, and this may sound insane, but doing performance testing in production is the best place to do performance testing, okay? And you might be thinking, well, that's probably not a good idea, but there are ways to actually do performance testing, or let me rephrase that, performance measurements on production without being intrusive and without slowing down your system. And again, if we want to think about this in terms of business analysts or customers or whatever, we can capture performance data on production without introducing risk into what we're trying to do. Okay? Of course, everything we do in software has risk. So even introducing unobtrusive tools has some risk, but we can minimize those risks so it's not problematic. Okay? Oh, sorry, I didn't hit the other slides. Okay, so if you can't convince your people to put in some stuff on production, then the next best thing is to have a full production mirror to run your performance test. And then, of course, you can set up a staging type of environment, which is not as big. And then you can just try running some synthetic performance test in a test environment, which is probably not very useful. Okay? Now, you might think, okay, well, you know what? The folks I work with, they're very risk averse, so they're not going to let me do anything on prod. So what do you mean by full production performance test? So at the telco that I used to work at here, after I convinced them that doing a nightly reboot of 150 JVMs was a bad idea, they said, okay, what's it going to take to fix this? I said, well, we can either do performance testing in production. Oh, no. That's crazy talk. Like, that's fine. Then what we need to do is we need to do 100% mirror of exactly everything we have in production. And this is kind of in the pre-cloud days, right? Just before the cloud, kind of took, actually, I don't know if this company is even completely on the cloud, but that's a different story. So, and they said, well, that's going to cost a lot of money. And I said, well, this is my solution. Let's run on prod. You don't want to do that. So our only other alternative is to build a full production environment just for doing performance testing. And this was when, again, this was a while ago. So we were running a full Oracle Exadata rack and also a cluster of approximately, I think, 80 Niagara chipset Sun servers, right, or Oracle servers at the time. Does anyone want to guess how much that cost to build out a full production environment or a mirrored production environment? It was close, about $2 million. But they thought it was worth the money to do that. So the moral of the story is, if you don't ask, you don't ever get anything. It may sound insane to you, but if the problem is big enough, then what's the easy way to fix any problem? You throw some money at it, right? And this is a way that you could throw some money and get some cool hardware. Anyways, we don't have that much of a problem with this nowadays, because what can you do today is, how many people are running on AWS, out of curiosity? Okay, that's not a lot. Azure? Okay. GCP, Google Cloud? Okay, there's a few more. Do the rest of you folks run on-prem or something else? Okay, what do you run on? Okay. Yep, Gelastic. Anybody else? Okay, and everybody else, I assume, is on-prem. Okay. Anyways, yeah.
So you said they spent $2 million a day, and we've been spending. So what if I say, this is production, I'm going to mimic 1/10 of production?
Yeah, that's not going to work. It sounds like a good idea in theory, but you won't get to the edge cases for your, of course, everything depends, right? But it typically doesn't work, because I'll tell you why. What did I skip over when I said, hey, this is like our full production environment? Right, number one is the load, but what does every app go and get stuff from? A database, right? So are you going to mirror your entire database? Yes, you have to pretty much, because that might be the bottleneck. But if you do that, if you only build out 1/10 of your environment, but you only mirror 1/10 of your database, are you going to expose underlying problems in your data store? So the short answer for let's just do 1/10 of what we have is, sure, try it, right? I'm not saying that you go in with your bat swinging and say, we got to build the whole thing up like, the same as we got in production right off the bat. You can build up to that. You can try it. If it works, great. But chances are it probably won't. Okay? So, yeah. Okay. So, again, production, full prod test, staging, etc. Best place to test is on prod. I'll show you some tools where you can actually test on prod. All right, so when we talk about environments, production performance analysis is always the best. We try to replicate things in a mirror test environment, which is possible. You can try to do it at a fraction of what you have in production, but that may not necessarily tease out all the problems. And then, of course, the biggest problem is, say you have 20 petabytes of data that you're hitting in a data store. What are you going to do about that? You're going to replicate that? Maybe you need to, maybe you don't, right? Maybe you can do something fancy to mock that, right? That's up to you at this point. Now, you don't necessarily have to build a full production performance environment that runs all the time. Now in the days of cloud, what can you do? You just write a Terraform. Everyone has Terraform scripts for their production environment, right? I see some people shaking their head no, which of course is true. Right? Because the problem with production environments is people just go hack stuff and add new servers and rebalance the VPN and all that kind of fun stuff, right? So that becomes problematic. So anyways, my point is that if you're diligent about keeping Terraform scripts, or if you really have a performance problem and you're running on AWS or GCP or an Azure or whatever, someone will have to go into a dark corner for about a month and write a Terraform script that looks exactly like what you have in production, so that what you can do is spin up 10 or 50 or 100 servers and get all the databases up and get all the networking exactly right, run a performance test for 5 or 6 or 10 hours, bring everything down so you're not giving AWS and Azure or GCP or whatever all your money. Okay, so the problem is actually solvable much easier now, where you don't need $2 million, but you just need engineering resources to write Terraform scripts that mirror your production environment. You bring everything up. You still have the problem with what do you do with your data? I don't know. Maybe you mirror all your data to read-only data sets, and then you run a perf test, and then you just, I don't know, right? That's something they have to figure out depending specifically on your application. All right, so we already talked about all this stuff. So one other additional trick here, like the gentleman in the back mentioned a second ago, is what you can possibly do is you might be able to get away with doing something that we've had some luck doing, which is the second bullet on this slide, which is do your performance testing in production, but just do it on one node in your cluster. So that way, again, what are we doing here? We're minimizing the risk of adding in this stuff. And so do it on one node in your cluster, and if that blows up, at least you don't lose everything, or at least you pray to God that you don't lose everything. But when we do production performance analysis, we do have unobtrusive tools like garbage collection logs, thread dumps, and something I'm going to introduce to you tonight called JHiccup, which is super helpful in understanding what's going on, even in a production environment, right? And in an unobtrusive way. And I've already mentioned cloud deployments already, so I don't want to go too much into this. I already talked about Terraform. So I do want to mention this whole horizontal scaling thing. I give another presentation where I talk about enterprise cloud patterns and what vertical and horizontal scaling mean. But I think someone over here mentioned that just add another node to your cluster and that'll solve your perf problems. Usually, but not always, right? Because if you have a lot of data moving over the network between your nodes, or if you have, gosh, what's it called? There's a diagram from Netflix where they have all their microservices pointing to each other, and it's called the Death Star pattern. You may have seen that before, okay? So if you have that kind of setup, is horizontal scaling really going to help you solve a performance problem? Maybe, maybe not, okay? So there are other things to consider like your network in the cloud, which is usually pretty good, and also storage in the cloud. What kind of storage are you using? And this may be a surprisingly easy way to fix your performance problems. Okay, so how many people run Kafka in here, out of curiosity? Okay, so a few people. What's the fastest way to speed up your Kafka cluster? Anyone want to take a guess? Come on. The answer is on this slide, by the way. Nope, not that. Nope, not that. It's the easiest way to speed up your Kafka cluster. Come on. Put faster disk on it, storage. All right? So, what's that? Yeah, NVMe SSDs all the way. It's the easiest way to speed things up. Actually, the price difference between spinning storage and NVMe SSD storage, it's substantial, but it's not that great. But you can, working with a customer recently where we swapped out the storage, and all of a sudden they saw like a 5 to 7x improvement in Kafka throughput, right? And he's shaking his head, so there's verification right there, right? Super easy to do. Problem solved. Now you can spend your weekend doing tequila shots or whatever you like to do, okay? So.
Or AWS even offers the option on the spinning disk anymore. They just do it straight to SSD.
For what?
AWS, for their Kafka.
Yeah, so the gentleman said, made a very good point actually, which is AWS with their managed Kafka cluster only offer it on SSDs.
They used to have a switch on there.
Oh, they used to have a switch. Okay.
But now it's not even on there.
Right, exactly.
Discovered that one because our Terraform blew up.
There you go. There you go. Okay. All right. So anyways, let's move on. The other thing that we need to think about when we work in the cloud is that, at least to me, it feels like CPU slicing in the cloud every year gets smaller and smaller and smaller. Maybe it's just me, right? It's like, hey, it's the chips are getting faster. Why aren't I getting, large? Yeah, so you guys know what I'm talking about. But it feels like we get less CPU cycles, slower storage, et cetera, maybe over provisioning on the cloud provider's part, et cetera. So anyways, these are the kinds of things that you need to look out for. Is anybody running on like AWS ARM processors yet? Are you going to start running on Graviton? Graviton, yeah. On AWS, it's called Graviton. I don't remember what it's called on Oracle Cloud, but okay. So Azul actually makes our VMs now run against Graviton, so it's worth checking out. And you can use the free one. Doesn't matter to me. I'm not in sales, so it doesn't matter to me. Okay. All right. Let's move on to the next bullet. Thinking about your app. This is probably the most difficult one to actually talk about because I don't know what you're running. Okay, I can just give you some basic guidelines from things that I've seen. All right, are you running Spring Boot or are you still running Java EE? Actually, that's a good question. How many people are still running Java EE apps? It's fine. You can raise your hand. The Java EE support group meets at the bar downstairs. So Spring Boot, let's see a show of hands real quick. Spring Boot, okay. All right, let me rephrase my question. Is anybody not running one of these two things to build Java apps? Yes, what are you doing? You're running Micronaut in production? Okay. So, sorry, who said yes? Which company do you work for out of curiosity? If you can tell me, if you don't mind. I'm just curious. The Home Depot is running Micronaut. Holy crap. I did not know that. You learn something new every day. How's that working out for you, by the way? What's that? Okay. I personally like Quarkus the best, but that's a different story. But Micronaut is great. Okay. Anybody else, aside from Spring Boot, Micronaut, and Java EE? Anyone using like Helidon? Anyone using Quarkus? Okay, so you are running some Quarkus in prod. Okay. You running on OpenShift? Okay. Count your lucky stars. Different story. All right, so are you doing event streaming with Kafka, right? Or with Pulsar or something like that? And of course, the other things that you have to look out for in your app is what kind of external locking. Someone mentioned this already. Are you using a database? Probably. Are you using a NIO-based JDBC database driver? No? Well, maybe time to think about doing that, okay? So again, this is the most difficult part for me at least because I don't know what different people's apps in this room are like, but some things to think about is reactive is not a silver bullet for this, right? A lot of people say that, oh, we'll just use reactive from top to bottom and everything will be magically better. That is true for a small number of use cases, but not generally speaking, right? Does anyone do reactive with Reactor or Vertex or anything? What's that? You did. Well, okay. So, oh, that's interesting. Okay, so your company went to reactive. They tried.
We had a particular application deployed in it, and yeah, it was not at all performant. It did not give what the implementers had promised, and they gave it a serious, like 2-year real attempt.
I got you. Okay. Yeah, sometimes. Got you. Yeah, so sometimes things don't work out, which is okay as long as you're able to admit that that's not working out, right, with no fault assigned or blame assigned, and you can move on and make things better. Which framework were you using for reactive? Was it Spring Reactor? Was it Vertex? Okay, so you're using Spring Reactor. Okay, that's really interesting because the typical typical improvements that people see when they go top to bottom reactive is you generally see a 5 to 7x improvement in performance, right? But everything depends on your app, right? What's your app doing? And there's lots of different nuances around that, but we can talk about that.
Very microservice-based,
Okay.
and messaging-based, and the streams and that kind of stuff from Kinesis.
Right, so you have streams, Kinesis.
And so it's a mix of those kinds of applications, everything. But maybe it was just nothing wrong, actually.
That's true. Could always be that. Well, let us know next month or next couple of months because I think that would be really interesting to see where that kind of project went wrong. But the problem that reactive faces, and you can correct me if I'm wrong, is that you have to write your code all in a reactive style, which I believe introduces two problems. The first is that it's more difficult to find out where problems are, bugs, etc. And the second one is that it affects code readability. Even with something nice like Project Reactor, right? Right. So reactive is not necessarily a silver bullet when it comes to fixing performance issues, because you have to, number one, rewrite the code, and in my opinion, it becomes less readable, and it's harder to debug when something blows up and you get an exception thrown. But that's not what this talk is about, so I'm going to move on. Okay? So other things to know about your app: is it long running? Are you running your Spring Boot application for hours and days, or are you running in a microservice environment where you're using Kubernetes or OpenShift auto-scaling, and your app size or the number of nodes goes up and down, et cetera, right? So these are things that you need to know about your app. Okay? A couple of other things. Are you sure you're distributing your load evenly? This may seem like a given, but I have seen people have uneven load across the same nodes, running the same app on different nodes in their cluster because of various networking issues or whatever it may be. Okay? But I think the biggest takeaway for this, and this is probably the only thing I can really generalize, is how much capacity is needed at peak. Right? Because that is, the peak is the peak. Right? When do you see the most capacity? During the day or during the month or week or whatever. Right? Because that's what, again, remember we talked about defining goals. Right? When you run a performance test, your performance test has to minimally reach this peak, and you have to figure out what this peak is. Right, and you can pretty easily do that. Right, all you have to do is look at your, if you're using some kind of tool like App Dynamics or whatever, or other monitoring things, you'll know when you're hitting peak, right, in terms of both load on the server itself and throughput that you're pushing through your system. Okay. All right, so moving swiftly on, let's talk about operating level system settings. And in this section, I can actually give you some specific things to look out for. All right, so time for a little trivia. Whether you're in a Docker container or on hard metal or in a virtual cloud instance, what should your U-limit be set to? Does anyone know what everyone knows what U-limit is? Okay, let me rephrase that. Who does not know what U-limit is? Okay, so U-limit is basically the number of file descriptors the maximum number of file descriptors that a process can have. Okay, so what should your U-limit be set to? Unlimited. All the time, every time, okay? Don't constrain your Java process artificially. Let the operating system melt down before your Java process melts down, okay? That's the short answer there. All right, so we'll talk about VM min-free kbytes in a second. LSOF is also a useful tool to see what kind of files are open and what kind of limits you may specifically have on like network sockets and things like that. These are kind of easy things to check for. Okay. Now, this minimum free kbytes on the VM, that applies mostly to swap. You should never, ever, ever swap. You turn that crap off, right? How you turn it off is on that second line right there. Okay. Now, okay, let me ask a question. Why should you never swap?
The whole paging system gets screwed up.
Right. You're introducing an artificial performance bottleneck. If you give your Java virtual machine, let's say you give it 512 megs of memory, but you have swap turned on for whatever reason, and maybe you have other stuff running on this server, okay? What happens when the amount of free memory starts getting low in the operating system in general? It will start to swap to disk. So it will take the memory that you have on the heap which your Java objects are sitting on, and it will spool them off onto disk because you're running out of memory, and when it needs them, it will spool them back into memory, and boom, you've created a performance bottleneck. So you never use swap. What you prefer to do is let your container or your server just blow up. I'm not joking. Just let it blow up, and now you know, well, we need to add more memory to this thing, or we need to reduce the amount of memory that we're giving the JVM. Because one of the things that I typically find is that people very, very wildly overestimate the amount of memory that they should give their JVM. That may be a surprising statement, and of course there's a big asterisk there. It depends on what your app is doing, of course, but if you're thinking of a Spring Boot application, how much memory does it really need, right? You can find this out just by running some perf tests typically and watching the heap. Right? It's actually not that difficult. We'll do that in a few minutes. All right, speaking of which, Let's talk about tools for performance testing. Yes, go ahead, please.
So, I know this is all great on the periphery, right? But what about the hardcore? You're a Java programmer, be responsible, release your file handlers, release your, object memory so GC can do its job better. Shouldn't that be at the center of your performance testing?
Absolutely not. Right? So the comment is, am I freeing enough objects? How am I doing memory management for all these different things that I'm doing in my app? Shouldn't that be at the center of performance testing? The answer to this is, if you start doing that, you get very, very little return on that kind of work that you're doing. Okay? And of course, the answer is it depends. If you have an obvious error or obvious thing that you created in your code, and you see your heap go like this and always stay pegged at the top, then yes, you have a problem and you have to go fix some low-level code. But 99 times out of 100, it's not something like that. And of course, I say that now. I used to work on, I'm going to take a quick aside and cut this out of the video, Ken, okay? I don't want to throw anybody under the bus here. When I used to work at a company here in Atlanta, I won't say which one, there was a programmer on my team who owned this bit of code, and every now and then, on production, that VM would just die. Like, no warning, no heap dump, nothing. It would just be gone like this. And we would know because that instance would automatically start back up, right? Everyone has auto restart and blah, 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 all that kind of stuff. And so we were all baffled for days. It's like, why is this one specific Java virtual machine running these 3 features would just die? Like, literally just dead. No warning. And so I started digging through the code, and I saw in one part of this code, he had a system.exit in there. So I went to this programmer, and I said, what is this here for? Oh, it's just there for test. This bit of code never runs. Guess what was happening, okay? So anyways, to your point, yes, so I think that if you have a problem in your code where you're not releasing objects, or you have circular references or things like that, they're actually pretty easy to find. Okay, you just have to, if you're doing code reviews, you should just find them at code reviews. But even if you have millions of lines of code, you can usually narrow that down, and those are the easy problems to solve, right? This is more about the hard problems to solve, more at the JVM and systems level, right? You can fire up Visual VM, point it to your VM, and if you see the heap always pegged at like 99 or whatever at the very, very top, and then you increase the memory of that VM, and it always takes that up, you increase it more, it always takes that up, then you have something that's holding on to memory too long, okay? And again, you just look through your code, and you'll probably find it relatively quickly, is my guess, okay? It's a good question, though. All right, so speaking of tools, we're going to look at Visual VM and the Visual VM garbage collection plugin in just a minute. I'm not going to talk about JFR or Java Flight Recorder, but this is what you can use to take profiling data, which essentially looks at threads, and you take those snapshots under load. We don't have time to look at that, but this is a good tool for using when you think that you have some kind of thread contention, or maybe there's something wrong with how you've designed your database access layer or something like that. Okay? And for doing load testing, we're going to use JMeter, but there's another tool in here that you can use called Gatling to simulate load. And then 2 command line tools I like to use are JStack and JStat. JStat gives you GC and memory outputs into your logs. JStack gives you essentially thread dumps with various different bells and whistles depending on what you want to get out of it. Okay, but the one tool I want to introduce to you is called JHiccup. I find this tool to be incredibly useful when speaking with performance people at different customers and stuff like that. Okay, what JHiccup does is it measures any kind of pause that can affect a running Java virtual machine. Now, the interesting thing here is that the pause can be from anything from the JVM on down, which means the operating system or whatever. Okay, so what we do is and this is a non-intrusive tool. It basically, I'll show you what it does in just a second. Okay, but what we do is we use the output that it produces, and we use a histogram log analyzer to see the output, And that's where you remember that chart where I was showing the P99 with the curve? It came from JHiccup, actually. Okay? And the way that it works, right, and the 1 second is not right, but just for explanation purposes, a thread sleeps for a second, wakes up, and records the last time since it went to sleep. And it just logs that timestamp. That's all it does. Okay? So this tool was actually invented by the CTO of Azul, Gil Tene, who's also a Java champion. Okay? So if we want to look at it visually, this is what it does. We sleep for a second, and we say, okay, I'm going to wake up, or millisecond. We're going to wake up and say, when was the last time I was awake? Was that a millisecond ago? It doesn't matter. It just records this timestamp. Right? That's actually all it does. Right? So if we look at that when there may be problems, when there may be problems, let's say this runs over 5 milliseconds. We record, and we can look to see if there was something that kept that thread from waking up and recording that timestamp every millisecond. So, and this is not a trick question. What is it that every Java application, virtually every Java application has, that would keep a thread like this from waking up every millisecond and recording a timestamp? Garbage collection, exactly. Okay? So as you'll see when we run this demo, hopefully we'll see when we run this demo, we'll see when the GC kicks in, we'll see JHiccup also spike and say it took way longer than 1 millisecond for me to wake up and record the timestamp. Okay? And the way that we use it is like this. We introduce this Java agent, JHiccup jar. That made it be unreadable a little bit because of this screen. But we're actually going to run the Spring Pet Clinic demo application as part of this little performance test. Okay? So the other tool that I'm going to use is I'm going to use the Azul Garbage Collection Log Analyzer. This specific tool is only available for Azul JVMs. Azul Zulu is based on OpenJDK. Well, so is Prime. But Zulu is completely free to use, whatever you want to do with it. That tool is yet to be released yet, but there are other tools that you can use. For example, gceasy.io is a really nice tool for looking at garbage collection statistics. And the reason why I mention this is, again, we're trying to use things which are non-intrusive and don't affect the operation of the JVM. Right? You can stick something like AppDynamics in, right? Does anybody use AppDynamics? Okay. What are some of the other what's that? There's Dynatrace. What are some of the other ones that people use? Anybody else use something else? Dynatrace, AppDynamics, etc. That's more for graphing, but yeah. Anybody else? There's an open source one. I can't remember the name of it. Yeah, there's actually an open source APM platform that you can use. But who here is using? You said you're using.
So AppDynamics last client, this client is Dynatrace.
Okay, so anybody else using AppDynamics or Dynatrace out of curiosity? Which one do you use? From? Oh, okay, I see a common theme here. Anybody else over here? Okay, so let me ask you a quick question. How much overhead do you think AppDynamics or Dynatrace introduces into your Java application? Okay. 3 to 5% overhead, right?
Not if you're running Dynatrace as a container watching your apps. All your apps are Docker containers. It doesn't instrument the code.
Right, but then you're not using it if you're not instrumenting the code.
Yes, you are, because it's watching all the data that goes around the pipe.
Nope, you're not recording in the JVM. You have to run the one agent in your JVM on the container. Otherwise, you don't get it. We just went through this whole
JVM
mess.
and Docker container, you don't have to.
Okay. So, so part of what you're saying is true, but and I could be mistaken. We could be mistaken. But if you want to get the full features of seeing everything that's happening in your Java app with AppDynamics or with Dynatrace or whatever, you do have to run its agent inside of it. Otherwise, you basically, it's just a black box at a certain level. So we can look that up later after the talk, though, just to verify. Okay. Anyways, so gentleman here said 3 to 5%. That's kind of a best case scenario in certain regards. It can actually be much higher than that. So anyways, this is why you probably heard me say this 1,000 times. How can we test stuff unobtrusively? Why do I keep saying unobtrusively? Because you want to convince your people that you want to run this where? On production. So you don't have to spend 3 months of your life trying to build out a prod-like environment, right? Because that seems super boring. Okay, anyways. Demo setup. We're going to use JMeter to drive this Spring Boot Pet Clinic app. We're going to use GC logging and JHiccup logging. So we're going to do this 100% non-intrusively. And we'll poke into this thing running Visual VM and Visual GC to see how this works. The Visual VM and Visual GC is for live viewing what's happening in your app. And then, of course, most of what we're going to do for real here, or in terms of looking at the performance, is going to be post-run analysis. Okay? So important words to keep track of. And I really hope this works, because sometimes it doesn't. Okay? Oh, don't want to drop my water. All right. So let's see what we got running here. Okay, so first of all, this is my histogram log analyzer. And this other thing is my Azul log analyzer. And then we have JMeter ready to go here. And then, of course, I have Visual VM. And if I zoom in here, you can see that my Spring Boot app is not running yet. Okay? So hopefully that doesn't make people dizzy, me zooming in and out like that. All right, so let's go and okay, let me go find the right command here. All right, so we're going to do Java. We're going to set the heap to be 64 megs because otherwise this test is super boring. We're going to use the JHiccup agent like we were talking about before. And of course, the rest of this you know. Dash jar, target, Spring Pet Clinic, blah, 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 blah. Okay. So, Glenn, have you ever run Pet Clinic before?
Maybe once or twice.
Okay, I'm a little disappointed at that. I'm just joking. Glenn works over at on the Spring team, so. But it's your reference application. All right, let's go run this. And let's see what happens. Okay, so this is going to start up, and we're up and running pretty quickly. Oh, you know, out of curiosity, everyone in here is running Spring, right? Spring Boot. What is your average startup time for your Spring app? Let's start over here. Just shout it out. 10 seconds, okay. Anybody else? You guys?
11 to 19 milliseconds. Oh, not milliseconds.
Seconds, okay. Over here? Anybody? How long does it take? What's that? 4 to 5 seconds. Wow, nobody has a Spring Boot app that takes like 5 minutes to start up anymore?
We have one that takes about 40 seconds.
40 seconds. What's that? What?
I listen to y'all. Like, it takes forever.
Okay, like is forever like 5 minutes or like 50 minutes or 5 hours?
If I'm running against Pride 20, 30 minutes. Like
20, 30 minutes.
You're sitting there for a whole, I mean, really 30 minutes.
Okay. No, there's no shame in that, because if you have a big app that's legacy, it takes a while to start up. So, all right. Anyway, so we got this running, and one of the reasons I asked that question is there's some new tech coming out called CRAC, or I don't like using the term crack, so I just say CRAC. But it's essentially instantaneous JVM startup without running GraalVM. So someone mentioned GraalVM over here a while ago, but yeah, it's we're getting to a point very soon where you don't have to have all the trade-offs that GraalVM forces you into, like no reflection and lots of other things, and getting like that near instantaneous sub 1 millisecond startup for even Spring Boot applications. So, what's that?
And what about JD?
Oh, yes, maybe. What version of Java? Yeah, it's still it's not experimental. It's kind of in the Java CRAC technology is what I would call it an alpha phase right now. So, but we're releasing a version for RVMs sometime, hopefully later this year, which will run on Spring Boot and Quarkus and other stuff like that. So, okay. What's that? Oh. Okay. All right, so here's our JMeter test. Let me just show you what this test does. It's not very interesting. It goes and gets the home page, it creates an owner, finds an owner, edits it, blah, 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 right? So it's just exercising the reference Spring Boot pet clinic application. So let's go start running this, but let's do this first. So now I'm gonna jump back into Visual VM, and here's my pet clinic app. I'm gonna double click on that. That's gonna bring this up, and I should have set this resolution to 1080p, but sorry about that. I don't wanna try to switch it out now. All right, so here's our app. What we have in the left pane here is the CPU usage. The top right pane is the heap usage. And you can see that this Pet Clinic app is using 40 megabytes with 0 load after starting. It's already done a garbage collection, by the way. So, and the other thing that I'm going to do is I like looking at this. So this is the Visual GC plugin for Visual VM. You can also run Visual GC on its own if you want. But here you go. Okay. So you can see here is, I don't know how much time I should spend on all these different things here, but this is the Eden or Young Gen. This is the old gen right here, but hopefully once we start this JMeter test, we'll see all this stuff take off. All right, so now we're running the test, and where's my window? That's fine. All right, so this should start taking off any minute now. Yep, so this should be running now. Maybe I need to ramp this up even harder. Let's see. So I currently have this set to 200 threads. The ramp up is 10 seconds. We're going to loop 100 times for all those different things. Let's check to see if all our threads are up and running. Okay, so you can see that our threads are mostly up and running now. Thread started. That's good. Let's just do this, actually. All right. So let's see how our VM is doing here. So you can see that it's slowly building and building. Looks like we did a garbage collection right here, but it very quickly went right back up. That's kind of interesting that the Eden did that. Right? It seems to be kind of spiky here. Or like the load doesn't seem to go like this. It just kind of jumps up and down at certain points. But we'll let this run for a second, or let's say a minute. But I'm going to talk about this a bit later. But while this is running, let me ask you all a question. How long do you think you should run a performance test? In number of minutes or whatever? Anyone want to just take a guess or what your opinion might be? How long should you run a performance test to get, let's not make it so open-ended. How long should you run a performance test to get some reasonably good results out of it? Okay. Summers, what do you think? I'm going to pick on you for a second. That's a great answer. I love that.
If your application performs terribly, not very long at all.
Okay.
If your application has weird bumps and hiccups, then until those bumps and hiccups show up. So, anywhere between like a minute, 30 minutes, an hour a day, depending on.
Okay. It's a good answer. So, so typically what we tell folks to do at Azul when we're helping people to look at performance problems is we tell them to run stuff for at least an hour. Okay. So part of the reasoning for that is the Java virtual machine has something called a JIT, or a just-in-time translator. And what that does is that takes your code, looks at all the code paths that you run through it, and optimizes the code. It does things like method inlining for code that's run lots so that you don't have to make a method jump to get a little bit of speed improvement, for example. Okay? So every Java virtual machine has some kind of JIT in it. Azul Prime we have our own JIT, which takes a little bit longer to warm up than the standard JVM, but it's a much better JIT. So to see like really steady state performance and to really push your JVM, you have to wait till the JIT is fully warmed up, is the technical term that we use for it. So, all right, so this has been running for a bit. So let's go and have a look at a couple of outputs. So this is the Azul GC log analyzer. So I'm going to say open file, and then go into our pet clinic, and we just open this guy. And then let's go look at our GC pause time. Okay? And why is this like this? Okay, let me make this full screen. All right, so this has been recorded, or sorry, not recorded. So one of the flags that I set was output the garbage collection statistics. So every time there's a GC, go and output what's going on, blah, 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 how long it takes. So you can see when the Spring Boot application was starting up here, all of you are familiar with Spring. When Spring starts up, it does a whole bunch of construction. You know, it looks at the annotations, it sets this up, creates objects, blah, 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 and then it doesn't need all those objects. So that's why you see those up-down lines at the very beginning, okay? But once that's done, you can see that I was running my mouth for a while, so there was no garbage collection. And then you can probably guess when I started the performance test or the load test here, okay? So it was right about here when we probably did our first big garbage collection. So this was at 268 seconds, and it was about a 10 millisecond pause, okay? Again, a lot of problems in the performance world are due to garbage collection. So you need to know when GC pauses happen, how long those pauses take. If it's a short pause like this, it's 10 milliseconds, and of course, it fits into your latency goal, then you're okay. If you have a latency, if you have a maximum latency of 10 milliseconds, would this be okay? No, because what's the latency here? It's 10 milliseconds. So if you're using a pause the world garbage collector and you get a latency of 10 milliseconds and one of your performance goals or your business goals is that all requests need to be serviced in less than 10 milliseconds, then this is no good, okay? I mean, 10 milliseconds is very short though, typically speaking for a GC. But yeah, so looking at just the garbage collection time, by just outputting it, you know, you can go and stare at this thing all you want, not that one, this one. And if we go back to the monitor, you'll see like, you know, a nice diagram of, and you can tell when the GCs are happening here, right? We don't need that, necessarily need that other diagram, but we're hooking into the VM while it's running. So when we hook into a running virtual machine, we're using Visual VM or any other tool, we're introducing some overhead here. So we want to try to avoid this on production. It's fine if you do it on your computer or in your test lab or whatever. But what we prefer to do in production is we prefer to, oh, looks like we're crashing the application, which is good. That was our intent. Let me go back to my slides. Right, so the way that we set this up with the garbage collection is these first few lines right here. Log all the GC details at the debug level into this file, okay? And again, this is unobtrusive. Yeah, it takes up a few cycles for it to go and dump that or basically print out the GC logs whenever it happens, but it is relatively unobtrusive. All right, so let's go back to this, right? So we can see that we're doing some garbage collections because we, especially at the beginning, when we told it to ramp up those 200 threads and start doing all that work over and over again, okay? Now, let's go look at the JHiccup log. If you remember what JHiccup was, that's the thing that says every millisecond I'm going to wake up and print out when I recorded that, and then we look at that and see if there are any pauses in that thread that's supposed to wake up every milliseconds, which will be indicative of problems that we may have both in our Java app or in our operating system, underlying operating system, or virtual machine, or whatever you want to call it. All right, so let's go open up that JHiccup log. And for that, we need to look at this thing, and this will take a second to load up. This will take a second to load up. Okay, this is not good.
How do you see, like, when you're talking about passive and active tracking of issues as far as like capturing that data, how does like metrics capture affect code for meaning, like if I'm sending something out to a time series database, you know, using micrometer or whatever to be able to do tracing or metrics, how has that impacted customers in the field?
So Glenn, are you specifically asking about like micrometer, for example, or micrometer or whatever?
Well, micrometer, well, I'm not worried about micrometer, but you know, some people could be hooking directly into like a Prometheus or to anything your favorite. You know, does that degrade performance? Have you seen some gotchas on that?
So I know that it does degrade performance, but how much, by how much, and what the gotchas are, I don't know the answer to that question off the top of my head. No.
Talking about that, I was like, I know a lot of people are like sending results to Datadog, for example, right?
Sorry, sending it to where?
To like Datadog or something like that.
Oh, right.
Things like that, so that's got to have an overhead. But yet, a lot of those metrics or traces are valuable, but at what cost?
You've
Right.
got a large application or a large install of microservices. It's next to impossible to tune them without that kind of visibility.
Right.
And I've kicked and fought to have that put in this latest project. And every day I have people come up and tell me just how much I've saved their lives. Because you think you know the performance of something until it's in the production environment. And you suddenly start realizing the things you assumed would be performant are not. The things that that you thought would be really slow. So you spend all this time optimizing code that never gets above a certain threshold in latency or in access time of disk or database. And then the little thing you gave no attention to is the thing that's like taking 2 seconds, 5 seconds in these calls. So I could not. It's funny to look at what you're putting up there because I haven't seen that side of it now for like the past, I guess, 6-7 years now.
Gotcha.
I mean, we're a Spring Boot shop. It's micrometer, micrometer, whatever you want to call it. It's actuators what it started life in Rock Wizard. And I can tell you right now.
Okay. So let me try to summarize what you two guys are talking about for everybody else. Okay. So there's a tool for Spring Boot and for microprofile called micrometer or micrometer, however you pronounce it, micrometer. And what it allows you to do is it allows you to get almost low-level performance kind of benchmarking from your microservice type of application. And what the gentleman here was saying is that it's super useful to identify problems at runtime in production. It's just a really nice tool, and I totally agree with that, right? There's certain tools worth putting in, right? App Dynamics and Dynatrace for a long time, especially for monoliths, it's like, well, this is kind of the only game in town. But Micrometer is really great for if you're running whether Spring Boot or Quarkus or whatever microservices and getting all those stats out of your Cube cluster, because the problem with running in Cube or OpenShift or whatever is that you have even less visibility than you would with a standard Spring Boot application running in a VM, right? So. Is that a good summary?
It's also, good summary. And another thing to think about is how do you scale an application? If you don't have those kind of metrics in real time, a lot of people, I see these people like the App Dynamics and the Dynatrace folk are always talking about it, they're always going into the CPU usage and the memory, and I'm looking at it going, okay, well, what is the actual query that is it running in this particular microservice that's causing the real time?
Yep.
To me, that is the real key, and you can actually begin to build your Kubernetes to scale based on that stimulus.
Yeah.
So it's one of these things when you get into a performance issue, you can't fix it in code because it is what it is, right? There's some of those things that just no matter what you're going to do, it's going to be a long query.
Yeah,
well, at that point, you can stimulate
functions as well as ephemeral apps, and so I mean and the good thing is you pick your database, your time series DB. And so it's generic enough you can plug in, like I said, an Influx or a Prometheus or Datadog, it doesn't matter. It says, okay, we'll plug into it and we'll report it. So that's what's also good.
That goes back to gentleman's question earlier about running the Dynatrace agent, one agent outside of the VM.
Right.
We have to expose the stupid port on there, 1099.
Oh, yeah. I don't remember, but yeah. The JMX, but yeah. Yes.
All the acronyms. But so now, in order to get those tools to pick up, because all of them pick up what is published by Micrometer, we'll just use that term. Now pick those up and display them. And it was kind of funny because when my company, my current client, actually saw the difference because they were so used to Dynatrace, and when they saw what was coming in, the micrometers, they were like, this is what we want. This is like, like what you were showing there with the visual VM, which is useful.
Yeah.
But it's not in depth because the person didn't have, and that might be something that you would like to
Right. So I agree with everything you say. Micrometer is a great tool. It's designed specifically for microservices. So if you're not building a microservice, not so useful, right? No, I'm not saying that you're wrong, right? But for the people in this room who are thinking, oh, wow, I'm running this Java EE app, maybe I should look at Micrometer, it's not the right tool for that. Okay, that's what I'm getting. Or if you're running a monolith-based Spring Boot application, again, probably not the right tool for that.
It would not be as useful in that situation because it being a monolithic app, you don't have it distributed across a large set of nodes and stuff. But you could use Drop Wizard because that's where I actually started using it in the beginning. Was way back when it was Drop Wizard.
All right, so let's get back on track and try to wrap up here quickly. So what I have here on the left is the garbage collection output in a graph with this GC log analyzer. On the right, I have our JHiccup. I finally got it to work. I was using the wrong VM for this, using two newer VM for this specific tool. But there's that graph that we were talking about at the beginning of this presentation. And if I zoom in here, right, so what we could do is we could look at this graph and we can say that our 99th percentile here was at approximately 2.5 milliseconds. Our P95 is about, I don't know, 1 millisecond. And then someone was asking over here about, like, how far into the nines do you want to go? And you can see if we go to 3 nines, then our latency here is about 26 milliseconds, okay? But what I want to demonstrate really quickly, and hopefully I get this right, is so this garbage collection pause happened at 268 seconds, milliseconds, seconds, what is that? Seconds, okay? Let's see when JHiccup detected. We should see a similar spike over here. Basically, we should be able to correlate a garbage collection on the left with JHiccup saying, my thread that's spinning, telling me how long it's been since I last reported in. We should see a similar spike here. So this is 268, and let's see if we go to 268, we should see, this is probably that peak right there, or maybe this one. Right, so it's right in this peak, you can see, this won't be exact because, you know, the way that JHiccup works, it only wakes up when the thread is available. So it's probably, actually, no, we can just do some quick math, right? So if we say at 268 plus 269 plus 10 seconds is about, what, 280 seconds. And so this one specifically was at 255, and you can see that was at 285. So it was at about almost exactly the same time if we added those numbers up, right? But again, the JHiccup log on the right, it includes everything from the JVM down. So it could be that maybe like my mail client woke up on this laptop, or if you're running in a Docker container or on a VM or something, if something was happening in the operating system itself and some other process started up, it would help you pinpoint that other stuff also running as well as what's happening in the VM. Okay? All right. So running a little over time, so let's quickly get through the rest of these slides. I've already shown all these tools, so I don't want to talk about those again. We did that. Collecting perf data, need to run for an hour. We already talked about that. We spoke about real load versus simulated load already. One important detail is we want to try to stay focused. Ignore everything else. We're engineers, so we like to look at like everything and try to solve the world, but try to focus on what your actual business metric is. We talked about how to set GC file logging, looking on perf data. We've already done most of this. We can consider changing garbage collection algorithms. There are different ones that will work for different types of applications, whether you're looking for throughput, low latency, etc. Does anybody set their garbage collection algorithm to what's not the default in their VM? Nobody. It's tempting. What's that? Okay. Right. I mean, you could change the garbage collection algorithm that you use, but it actually, I'm happy to see that people don't do that because that is actually a black hole of time and usually doesn't get you to where you need to go. Okay, we looked at visual VM, we talked about JFR, we talked already about the JIT warm-up time. There's also something called garbage collection warm-up time, which we saw when we started our Spring Boot application. And finding bottlenecks, we looked at correlating JHiccup latency with garbage collection and other threat contention types of things. Also OS bottlenecks with JHiccup. We can take stack dumps, thread dumps using JStack. And if this is truly a problem, you can either use JFR to do this, take profiling information. If you want to be less intrusive, just set up a little bash script that dumps the stack every 5 seconds or 30 seconds or 1 minute, depending on your application. And then you can pull that into a tool like jstack.review, or you can use something like the JProfiler app, or IBM has a nice tool called the Thread Dump Something Analyzer. I don't know what that M stands for, but okay. We can also take heap dumps. Heap dumps, I find generally are not super useful, but what is useful is heap dump on out-of-memory error. So if you do get out-of-memory errors, you should definitely have this, because if you don't, then you have no idea what happened. At least you get a heap dump and you can see what's in there. And then the fix and repeat is pretty self-explanatory, one fix at a time, and that's pretty much it. All right, so we finished a few minutes late, so I apologize for that, but we'll take, where's Vince at, or Glenn? Take a couple of questions. Okay, sure. All right, any questions? I think people have been asking questions already, so that's great.
What, I think RA, we can give that to me now or later? Hang in.
I don't have to get up. I don't think I need to get up, do I? Want me to get up?
No, just tell me, I'll re-announce it.
Has been selected. No, I'm just kidding.
Hey, there you go.